Hello everyone, welcome to Anu's classroom. So you guys have been asking a lot about the numerical questions on how you can solve the various numerical questions that have come in the term and examination for MMPC 5 specifically. So it's been a pending video topic since so long. I've always wanted to make this, but now I've got the time. So I've decided that I'll make a series of videos wherein we'll take a few questions from the term and examinations which have happened in the past, and we will look at how we can solve those term and examination questions in the hope that you guys will be much more prepared to face your upcoming term and examination on MMPC 5. Now, if you are new to statistics and all these probability concepts and all, if you are not very strong in these particular topics, I would suggest don't spend a lot of time in this and rather use whatever time you have got to focus on the theory part of MMPC 5. The reason why I'm saying is numericals are not necessary to get a pass mark. Like if you have written your assignments in a decent manner and you can expect, let's say, at least a B grade in your assignments, if you focus on the theory part of MMPC 5, okay, because you just need to pass in MMPC 5 theory, like term and examination, you just have to get 40 marks out of 100, right? So if you can write at least 3 questions properly, decently, you will get those 40 marks and you will definitely pass. So if your aim is to just pass your term and examination, and if max or this probability, statistics, all these kind of concepts have not been your stronghold, then don't worry too much about it. You can pass even without doing a single numerical question. Okay, but if your aim is to like get an A grade or B grade or something like that in term and examination, then definitely these numericals are going to help. Sometimes, so the type of numericals that come in your term and examination is purely out of luck. Certain years we've got to see like very simple, very straightforward, very easy numerical questions, whereas certain years are like a bit tough, like has a lot of steps to do, things like that. And in certain years we have a very good balance of little complex as well as simple numerical questions. Okay, so in this first part of this term and examination numericals discussion, we will look at a couple of term and examination questions that have come up in the past. So enough with the intro, let us get started with the questions. So the first question that we have with us today is a term and examination question which have come up in the past. So the question is like this: the overall percentage of failure in a certain examination is given. So the failure percentage is given as 40%. Okay, and we are asked to find out what is the probability that out of a group of 6 candidates, at least 4 will pass the examination. Okay, so that is the question. Now, if we look closely at this particular question, we can observe that the experiment in question is what? So this is a probability question. Okay, that is the first thing. And so and this probability question is talking about an experiment. So I hope you remember what are like the basic concepts of probability, like events, experiment, variables, random variables, all those things. Okay, I hope you do that. I hope you remember it. I'm not going into detail on those things. Okay, so here the question or the experiment in this particular question is an examination. So if this is an examination, and when a person or when a student or a candidate is subjected to a particular experiment, that is in this case an examination, what are the possible outcomes that could come, right? Okay, so there is an exam, let's say our term and examination, okay, and you are appearing for this term and examination. What are the two possible outcomes? You could either pass or you may fail. Is there an in between? No. That is, there are only two possible outcomes of this particular examination. Either the student is going to pass the exam or the student is going to fail the exam. There is nothing in between. So no matter how many times we repeat this experiment, no matter what are the number of students that you are subjecting to this particular experiment, there will only be one of two possibilities: pass or fail. And we always assume, unless given specifically, that this is a fair experiment. That is, this is a fair experiment. The relatives of politicians or what you can say film stars and all will not be given any concession, right? So it's a fair examination. As such, what can you tell about the probability that is associated with each of these outcomes? It will be a 50-50 chance, right? there is a 50% chance that when you sit for the term and examination, you pass or you may fail. And this will remain a constant for each attempt. You write your MMPC 5 exam or your MMPC 4 exam, 6 exam, 7 exam, whatever it is, there is always a 50% chance that you may pass or fail. Just because you passed in MMPC 1 does not guarantee you will pass in MMPC 5. Just because you flunked in one of the papers does not make you a failure in all the other courses as well, right? So that is what. So it is a 50% chance, which is a constant for each attempt. So this is similar to the coin tossing experiment, if you can get where I'm going with it, right? Similarly, if you think about it, you passing does not guarantee your friend also passing, or your friend passing does not guarantee you passing, correct? So one student passing will not guarantee the next one will also pass. Okay, so what does all these things mean? It all means that the attempts are always independent of each other. Now, there is a name for such distributions in probability which follow these set of rules. Do you know what that is? I hope you do. I really hope you do. This is a type of binomial distribution. Okay, so this is what we have to use in order to solve this particular question. Now, how do we solve problems that involve such binomial distributions? We have to know what formula we have to use to solve such questions. Once we figure out that it is a binomial distribution formula, immediately we have to know what is the formula used to calculate the probability if a particular experiment follows the binomial distribution. Okay, so what is the formula? Let us rewind once. The formula for finding the probability for a particular event like x, say r, x is equal to r is NCR p raised to r q raised to n minus r, right? So what is NCR? NCR is nothing but n factorial divided by r factorial into n minus r factorial. P is the probability that the student will pass, and Q is the probability that the student will fail. In both these cases, it is 0.5 because it is a fair examination. Now, so we need to identify, as I said, there are a few variables in this particular equation, right? In this particular formula that we have with us. What are they? We have N, okay? So we have N, we have R, we have P, we have Q. So these four things we need to figure out. Okay, so first is N. N is the number of trials. So how many trials are there? The answer is 6. Why? Because it is a group of 6 students. Now, what is the probability of success here? I'll come to R, okay? Let's keep R pending as of now, okay? We'll come to R. First, let us find out the remaining things except R. What is P? P is the probability of success. It is a fair examination. Is it a fair examination? Okay. Okay, is it a fair examination? I told, if unless specified, it will be fair examination. Now, is it a fair examination? It is not. Why? Because the overall percentage of failure is 40. It is not 50%. That means out of 100 people attending this particular examination, 60 people are passing. So, it is not a pure 50% chance here. So, the probability of failure is 40%. So, that is Q is 40%. We are told that is nothing but 0.4. Okay, but so the probability of passing is 60% here. Okay, that is, it is a 0.6. Totally, when we add it up, we'll again get 1, right? So that we have to ensure. If you add P and Q together, you should get 1. Okay, if you're not getting 1, that means there is some issue in the calculation. Okay, so that the what you can say, it is a fairly easy examination. Why? Because 60% people are passing. So we got P and Q. So now what are we asked to find? That when a group of 6 people are attending this particular examination, what is the probability that at least 4 people will pass the examination? That means what? You can think of it in 2 ways, okay? At least 4 people passing means R will be, we have to find R for at least 4 means there will be 4 or more people passing, correct? R for 4 people passing, R for 5 people passing, and R for 6 people passing, correct? So if we can find out what is the probability that exactly 4 people pass, exactly 5 people pass, or exactly 6 people pass, and we add all of these up, then we will get the probability that at least 4 people will pass. Or, okay, so probability of x is equal to 4 plus probability of x is equal to 5 plus probability of x is equal to 6. If we can either add up like this, or we can say 1 minus probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 can also. So 0, 1, 2, 3, all of these together and minus it from 1. 1 minus. Why 1 minus? Because the maximum probability of any particular event can only be 1. It cannot exceed 1. That is why. Okay. So these are two ways in which you can find the probability. Since this particular one is where the least number of calculation is involved, let us pick this. Okay, here we have to do one more set of calculations, so we are not going with this, we'll go with this so that our job becomes easy. Okay, so probability of x greater than or equal to 4 is nothing but probability of x equal to 4, x equal to 5 and x equal to 6 all added together. So we have to figure out 3 where x is equal to 4, where x is equal to 5 and x is equal to 6. All these 3 you have to find out and you have to sum them all up together. So the first place where you're finding probability of x is equal to 4, what is r? R is 4. Second time when you're finding probability of x is equal to 5, what is r? R is 6. Third time when you're finding probability of x is equal to 6, what is r? It is 6. So for each of this, substitute your n. N, P and Q remains the same, only R is what is changing. Substitute the values of N, P, Q and R and all of these things in this particular formula and you figure out what is the probability. Okay, so when I calculated, I'll just give you, when I calculated it came to be around 5.4 something like that, 54%, 54 point something percentage I got. Okay, I got it as something 54% probability that at least 4 people will pass out of 6 when a group of 6 people will write this exam. But check if your answer was similar to this and you comment down below. Okay, so that is how we can solve such a question. This is one of the relatively very easy questions that have come up in the term and examination. Since this is a very first video, I thought we will rather tackle something very simple. Okay, so now let us go and look at another problem. Okay, so in this problem, what are we told? We are told that we are tossing a coin. Okay, so let us again assume that this coin is a fair coin unless it is set specifically, right? So a coin is tossed how many times? 6 times. Assuming it is a fair coin. Okay, we are assuming it is a fair coin. The fair coin is tossed 6 times. So again, once again, this is a binomial distribution problem. So what is our formula? Formula is P of x is equal to r is NCR P raised to r Q raised to n minus r. Make sure you remember this formula. Okay, whenever you see a binomial distribution, whenever you see something like this, binomial means what? 2 possibilities. Okay, binomial. What is binomial? You look at this keyword here, bi. Bi means what? Bi means 2. If your experiment is having only 2 possibilities, then it is a binomial distribution. You think like that. Okay, then it will be easy. Okay, so again, as I said, we have to use this formula. So what is n here? N is 6. N is 6. Now, what is the probability of obtaining 4 or more heads? That is one part of the question. And the second part is, what is the probability of getting at least 2 heads? This is the second part of the question. Okay, so let us look at the first part first. Okay, what is the first part? The probability of obtaining 4 or more heads. Again, probability of x is greater than or equal to 4. X is greater than or equal to 4. What is that? Probability of x is equal to 4 plus probability of x is equal to 5 plus the probability of x is equal to 6. You add it all up, you will get the probability. Again, what is P? What is Q? P is 0.5, Q is 0.5. Why? Because here it is not said that after 6 times, if suppose say like the last question, it was told that 40% people will are found to be failed. So like that, here there is nothing given like out of 6 times, 2 times head came up. Nothing like that is given. Right, so that means it is a fair coin. Fair coin means there is an equal chance that this coin will come as a head or it will fall as a tail. So P and Q is 50-50. Okay, then so P is there, Q is there, N we know, N is nothing but 6. Now this is first time p of x, this is r. Next time x is equal to 5, so that means r is 5. Next time probability of x is equal to 6 means r is 6. So all these values you substitute in this particular formula and you will get each of these probabilities individually. Add up all these probabilities together, you will get the final probability. Okay. Now to get the probability, so the second part is what is the probability of getting at least 2 heads. Okay, so probability of getting at least 2 heads means probability of x is greater than or equal to 2. So probability of x is greater than or equal to 2, we can say probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is greater than or equal to 4, right? This thing, we can either do that. Okay, this is one method, or we can say probability of x is equal to 0 plus probability of x is equal to 1. This will also give us the probability. So whichever you feel convenient, you take that and you find out the probabilities and substitute in this one of these formulas. Whichever you are picking, you substitute in that, you will get the answer. When I ran the formula for the first question, that is probability of getting 4 or more heads, I got it as approximately 34%, and of getting at least 2 heads, I got it as approximately 89%. I'm just giving you a rough estimate, like a rough value. Why? Because I want you guys to do the calculation and see whether it is closer to this. Okay, so that you can also verify that your answer is right, that you are doing it in the right direction, you are proceeding in the right direction. That is why. But whatever is the exact answer you got, you please let me know in the comment section, so that will help our fellow community members also to gain that traction. All right, so those were 2 of the questions that has come up in the term and examination. Now I want to draw your attention to a very, very important part of this video. That is, tomorrow when you are appearing for your term and examination and you see a question asking you to find the probability, how will you identify if you have to use this binomial distribution formula or not? Okay, very important point that we should know. Now there are a few things that you can look out for in order to confirm whether you have to use binomial distribution formula or not. Okay, so you can look out for certain phrases in your question, like there are fixed trials, okay, like 6 times the coin was tossed, something like that, a fixed number of trials, or that the percentage of success was so and so, failure was so and so, like that. You will see. Or maybe they are saying there is a constant probability, something like that. If you see these kind of keywords in your question, 90% of the time it would be a binomial distribution formula. Okay, now once you have identified that this is a binomial distribution formula, what you have to do is you have to break down the questions into steps. So like as we tackled, right, we have to identify what is n, what is p, what is q, okay, and what is r. All these things you identify. Once you identify, you can what you can say, once you have identified this n, p, q, r, all these things, and you have confirmed that this is a binomial distribution, we can now put everything in our formula. So you have to memorize this binomial distribution formula before you step into your examination hall. Only then you will be able to substitute these values and actually find out the answer, right? So memorize this formula. Once you figure out what is n, what is r, what is p, what is q and all, you substitute those values in this formula and find the answer. Right? Now, when you write the answer, make sure that you are showing calculations for all the coefficients, the probabilities, the sums, all these things, like every step. Okay, every step you show. Why? Because even if your final answer unfortunately goes wrong also, till the step that you have proceeded correctly, at least till there you will get partial credit. Okay, so even if your final answer is wrong, you will get marks for the steps. All will not be lost. Okay, so that is why. Now if you are feeling a bit overwhelmed, if you are not feeling like you have the speed to do these questions answers in a reasonable amount of time, don't worry. I don't know how close you are to your term and examination, but definitely with practice, solving these problems will definitely become quick and intuitive. Okay, so don't worry. Just make sure you memorize the formula, memorize how you can identify whether to use this formula or not, and you can take your calculator with you, so that is also a very big relief for us. So use your calculator well, and you will be able to solve the answer properly. Now, if you are interested in learning more about this particular concept, that is this binomial distribution and all, we have a video in our Anu's classroom, a part of our deep dive. I will leave a link to that video somewhere in the screen or in the description box as is possible. So you can look into that video so that you can get familiarized with the theory and the whole concept. Okay. So we have only discussed these two videos. I've kept this video intentionally short. We'll just be going like 1, 2 or 3 questions little by little only. So this we'll be discussing almost all the term and examination questions, but we'll be doing it like this in a short form so that you can focus on areas that you feel tough. Okay. So I hope we will meet again in the next video where we will be looking at some more other types of numerical questions that have come up in the past. So you are prepared to face them if they do show up in your term and examination. Okay. So until then, all the very best for your upcoming examinations. Study well.